ACS is a company specialized in high-efficiency cyclones. Numerical optimization and investigation of particle agglomeration in cyclones allows ACS to simulate millions of virtual prototypes in an affordable period in order to select the best for each given application. Presently, ACS has a wide range of cyclones to serve multiple gas-solid separation needs, both for emission control and powder recovery applications. ACS Pre Separators target dust reduction at the lowest cost, space and pressure drop, even for large flow rates. Built to withstand abrasive dusts and temperatures up to 1000 degrees Celsius, these heavy-duty cyclones are ideal to reduce sparks, carbon and silica in boilers, furnaces and dryers. ACS cost-efficient final stage cyclones. Numerically optimized high-efficiency cyclones, with emissions down to 1/3 of those of regular multi-cyclones. Moderately strict emission limits can be attained with these cyclones in several applications. ACS high-end agglomerator cyclones. To exempt bag filters and ESBs, complying with very strict emission limits, down to 30 mg per normal cubic meter, and to maximize recovery of valuable powders, such as food ingredients and APIs, thanks to the clustering of particles. Looking into a real case, each cyclone geometry presents a different performance, and therefore, different residual emissions. However, any cyclone family can be further improved in a second step, whenever emission limits become stricter, by adding recirculation and maintaining the existing collectors. A mechanical recyclone is made up of a high-efficiency hurricane and a particle separator, placed downstream, called the mechanical recirculator. The main purpose of the recirculator is to reintroduce the uncaptured particles into the cyclones, after they have been driven to its outer walls by centrifugal forces. While this gas is enriched in particles, the axial gas stream exhaust to the stack is clean of particles. Recirculation is achieved through an additional fan. A recyclone MH decreases emissions of hurricane cyclones alone by 30 to 50%. With electrostatic recirculation, a DC high voltage is applied to the recirculator, allowing the recirculation of very fine nanometric particles, more resistant to centrifugal forces, to the cyclone collector. After having been separated in the recirculator and concentrated in the recirculation flow, electrically charged fine particles are attracted by the cyclone walls, while agglomerating with larger ones, entering the system, both promoting their easier capture. With a recyclone EH, very low emissions are achievable for any high-efficiency geometry, even for the most difficult cases.